This video tutorial looks at the mathematical strand of measurement and geometry, and more specifically we're going to focus our understanding on determining congruent triangles. So what is it that makes two triangles congruent? Well, similar to the video on congruent figures, two triangles are congruent if they are identical in every aspect except for position. So if the sides are the same length and the angles are the same, they're going to be congruent. It doesn't matter if they've been rotated, reflected, or translated. If their side lengths are the same and their angles are the same, they will be the same size in every aspect except for position. Alright? If we are given enough information about a triangle, there is only one way in which it can be drawn. And because of this, then these particular triangles must be congruent. So on this slide are some rules for congruent triangles. There are 4 of them. The first one says that if all corresponding sides are equal in length, then the triangles must be congruent. And this is called the SSS rule, or side, side, side. In the example, you can see that the shortest length corresponds to the shortest length on the second triangle. The longest length has 3 dashes in it, as does this longest length, and the middle length has 2 dashes and 2 dashes. They are all corresponding. Therefore, we can say that these triangles are congruent because their corresponding lengths are equal in length. The next rule says 2 sides and an included angle are equal. And as you can see, we have an angle and an angle. It's the same angle. It's given the same angle because it's a dot. And the 2 sides connecting to that angle, these ones are the same length, and these ones are the same length. So therefore, the rule is SAS, which is side, angle, side. So 2 sides and 1 angle are the same. In our third rule, we have 2 angles and a pair of corresponding sides. So as you can see, we have an angle represented by a dot and a dot. We have an angle represented by an X and an X. And if you look at the side opposite the X, it's actually the same length. Okay, here and here. Because of that, that's a corresponding side. Both of those sides are opposite the X value angle. Therefore, because they're the same length, they have to be corresponding congruent triangles. And for our last rule, it's called the right-hand side, or right-angled side. Means the hypotenuse, one side, and a right angle. So right angle, hypotenuse, and side. You can see that both triangles have a right angle. You can see that opposite the right angle, the sides are actually the same length, so that's our hypotenuse. And then you can also see that a corresponding side connecting the right angle and the hypotenuse is the same length. So that gives us our right angle, our hypotenuse, and our corresponding side. Okay, so let's have a look at some example questions here. It says, are the following pairs of triangles congruent? If so, state the congruence relationship and give a brief reason. Now, if we look at question A, we can see that both triangles have a side length with 1 dash. Both triangles have a side length with 2 dashes, and both triangles have a side with length 3 dashes. So we can say for question A, yes, they are congruent, and the reason is side, 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 because the 3 sides are equal. For question B, we have a right angle and a right angle. Now the side opposite the right angle has 1 dash, and this side opposite the right angle has 1 dash. Now all we need is another side that is the same length, 2 dashes and 2 dashes. Perfect. So we can say yes, and the reason why is the right angle, the hypotenuse, and a corresponding side. For question C, well, we can see that one triangle has an angle of alpha, and so does the other triangle. One triangle has an angle of beta, and so does the other triangle. And the line that actually connects the alpha and beta angles has a length of 1 dash, and so does the other triangle. So we can say yes, and the reason is angle, angle, corresponding side. I'll see if I can write that a little bit neater. Angle, angle, corresponding side. Let's check our last one. Our last example, we have an angle of alpha and an angle of alpha, perfect. We have an angle of beta and an angle of beta, perfect. In our first triangle, the side length with 1 dash is actually opposite alpha. But in our second triangle, the side with 1 dash is actually opposite beta. So therefore, because that is not a corresponding side, we'd say no. The angle would normally be AA corresponding, but in this particular case, they are not congruent triangles. Okay, so here is a practice question I'd like you to have a go at. I'd like you to determine if the two triangles below are congruent, and if so, what rule makes them congruent. Please feel free to pause the video. Once you think you've got the right answer, continue the video and we'll see how you went. Okay, so let's see how you went. In these particular triangles, both triangles have an angle that is the same. It's represented by the dot. Now the two sides of these triangles that actually make that angle have a 2 dash and a 1 dash. Therefore we can say yes, they are congruent, and the rule is the side angle side rule. Okay, remember that if you have two corresponding sides and an equal angle, then the triangles must be congruent.